Um, Chapter 4, alright, radicals. Psh, radicals, who needs radicals? Functions, okay, functions are basic as basic can be. Functions, composition, inverse, whatever, variation, who cares? Functions are functions. You can just do that easy, it's okay. Chapter 5, though, quadratic functions and complex numbers. This is interesting stuff. I know I already made a video on completing the square, but I want to just try it. So let's try completing the square, the first thing, because that's what this 5-1. Real roots of a quadratic equation, real roots of a polynomial function are the x-coordinates. Alright, so if we have a graph like this, and we have some kind of function like that looks a little something like this, whoop, the roots are going to be right here and right here. You probably know that already. So one method you can do it is you can factor, you can do all sorts of things. You can use the quadratic equation, you can do grouping, you can also do completing the square, which I'm going to do right now. I know I already made a video on this, but you know, helps to do new versions every now and again. So when we have the equation y is equal to x squared plus 2x minus 1, and we tell you what are the roots. To find the roots, we have to do something called completing the square, because sometimes just normal factoring just doesn't cut it. Because normal factoring, you can't do anything to this, as you can see. So what you do is, first of all, you bring this y over to the right side. At least I personally do that because it's easier for me. To find the roots, we know that the x-intercepts has to be equal. In other words, y has to be 0. So we'll replace y is 0 because that's the x-intercept, right? So now what we do is we're going to move the c. This is the c term. We're going to move it to the right side of the equation. So in this case, we're adding 1 to both sides, and that's going to leave us with x squared plus 2x equals 1. Now what we're going to do is recall that x plus a squared is equal to x squared plus 2ax plus a squared, right? So if we pattern match, completing the square essentially is getting this x plus a squared format in the left-hand side here. So how do we do that? Well, we take the b term, this is the b term right here, we halve the b term, so we divide it in half, so 2 divided by 2 is 1, so that's us halving it. And then we square that, so 1 squared is just 1. So first we halve it, and then we square the b term here. So what we're going to do here is we divide 2 in half and then square it, plus 1, and whatever we do to the left-hand side, we do to the right-hand side. So now we're left with x squared plus 2x plus 1 is equal to, 2. And now we can pattern match. What is a here in this equation? Well, a, if you can pattern match, this is now in the same exact format that this is. So you can argue that 2x is equal to 2ax in this picture. So when we divide by 2x and 2x, this becomes 1, and 1 is equal to a. So we know that our a is 1. So when we pattern match, we know that this left-hand side equation is now equal to x plus 1 squared is equal to 2. Now we can just solve for x. We take the square root of both sides. X plus 1 is equal to plus or minus 2. I'm sorry, not plus minus 2. The plus and minus rad 2. And then when we subtract 1 from both sides, we're going to get plus minus rad 2 minus 1. That is going to be our answer. So there are two solutions or roots to this equation. One is negative 1 plus rad 2, and the second is negative 1 minus rad 2. These are our two solutions, or roots, as we can say. So that's completing the square. Alright, so let's have a go at another one. Let's flip this. Alright, let's try this one. Negative x squared minus 4x plus 2 equal to 0. We're going to find the roots. Oh my god, what was that? I don't know, that was kind of scary. So, first thing we're going to do is, I don't like this negative coefficient here. It's hard to work with, so we're going to just divide everything by -1. What that does is it just flips all the signs. And now we can move the c term to the right-hand side. X squared plus 4x is equal to 2. And now what we do is we complete the square. We have the b term here, 4, and then we square it. So as you can see here, this is just going to be x squared plus 4x plus 4. Why? Because 4 divided by 2 is 2, and 2 squared is 4. And whatever we do to the left-hand side, we're going to do to the right-hand side. So now this becomes x plus 2 squared is equal to 6, because this thing, if you look at the x squared plus 2ax plus a squared form, a, if you pattern match, is equal to 2. So now we take the square root of both sides, we get x plus 2 is equal to plus or minus rad 6, and now we get x is equal to plus or minus rad 6 minus 2. So we have two roots here. The first root is -2 plus rad 6, and the second root is -2 minus rad 6. Easy peasy. Okay, so that's completing the square, and you are going to have radical roots in your answer. That's normal. That is normal. That you can be rest assured that those are actual exact numbers. They aren't approximations. So, just to make sure you get the hang of this, you get the point, let's do a hard one. Let's do 2x squared minus x minus 1. Equals 0, of course. So, the first thing we're going to do is, we could always do the c to the right-hand side before or after. I'm just going to do it before here. So we get 2x squared minus x is equal to 1. Okay, easy peasy. I don't like coefficients on my a term, so I'm going to divide everything by 2. This is going to mean x squared minus 1/2 x is equal to 1/2. Alright, so now we do have fractions in it now, but that's okay. We do the same thing as before. We have the b term and then we square it. So what's 1/2 divided by 2? What is that? So divided by 2, well, that's going to be -1/2 multiplied by 1/2, which is just -1/4. Okay. So what about when we square -1/4? What happens? Well, it becomes 1/16, right? So what we're going to do is we're going to do x squared minus 1/2 x plus 1/16 on both sides of this equation. Alright. And now a cool trick is this x plus a squared, whatever you put in this a is always going to be the half of the b term. So half of 1/2 is -1/4, so that is what we're going to put. It's just a cool, it's a GTK, it's good to know. So now that we add all of this on both sides, so let's bring it up over here. This is a bit more involved, but we get x minus 1/4 squared is equal to, let's see, 8/16 plus 1/16 is equal to 9/16. 9/16. So now we're going to take the square root of both sides. So so x minus 1/4 is equal to positive negative radical 9/16. And as you can see, 9/16, they're both perfect squares, so we can simplify this to plus or minus 3/4. Alright, no more radicals in this problem. So now when we add x, we're going to get 1/4 plus or minus 3/4. So what are our solutions here? Well, if we do the 1/4 plus 3 over 4, we get x is 1, or if we do the minus thing, we get x is equal to negative 1/2. So that's a bit more involved, but as you can see, completing the square is very useful, and it has many applications. And it really greatens your knowledge, I don't know, your skill set, I guess. It expands your skill set, so you can solve a wider breadth of these factoring problems. So now what we do is, let's see what we want to do now. This is really interesting. Graph this and do the completing the square that way, but we're not going to do that because I suck at drawing graphs, and that's that. Alright, now let's derive the quadratic formula. Actually, let's do that next video. This is getting kind of long, and I do want to just upload these raw because I'm too lazy to edit them, and I'm supposed to be prolific while I'm recording this, no cuts or whatever. So, see you guys.